Good afternoon to everyone. Now I am going to deliver a speech on some basics of organic chemistry. Now organic chemistry deals with organic molecules which contains covalent bond, and each covalent bond carries two electrons, and this covalent bond can cleave in two types, that is fission of a covalent bond can take place in two types. One is homolytic fission and another is heterolytic fission. Now homolytic fission, the breaking of covalent bond in a manner that each of the two species formed retains one electron of the shared electron pair is called a homolytic fission. In this case, the shared electron pair, each atom carries one electron each, so that this one will give this fraction A radical and B radical. That is, this leads to formation of highly reactive neutral species containing unpaired electron known as free radicals. Now these are free radicals, and this homolytic fission, this one takes place in presence of heat, light, or in presence of peroxides. Now next one is heterolytic fission. Now in heterolytic fission, the breaking of a covalent bond in a manner in which ions are formed as reaction intermediates is called heterolytic fission. This involves the breaking of a bond in which a way that both the electrons of the shared pair are carried out by one of them. This can take place in two different ways. If electronegativity of carbon C is greater than X, then the molecule CX breaks up in such a manner that this carbon, the C remains the covalently shared electron pair as, that is, X as positively charged, that is X positive. And second one is, if the electronegativity of carbon C is less than X, then the molecule breaks up in such a way that X retains the shared electron pair, leaving carbon, that is C, as positively charged. That is, this A bond B, this one breaks in such a way that this A will be positively charged and B will be negatively charged. The group which contains negatively charged carbon atom, as in the first type of heterolytic fission, is called a carbon ion, whereas the group which contains positively charged carbon atom, as in the second type of heterolytic fission, is called a carbocation. That is, if carbon carries a negative charge, then this one will be a carbon ion, and if carbon contains a positive charge, then this one will be a carbocation. Now next one is electron displacement in covalent bonds. Now in covalent bond, electron displacement takes place in different ways. One way is the inductive effect. When the halogen atom X, more electronegative than carbon, is attached to end of the chain, that is this chain, at the end of this chain of the carbon chain, the electron pair of carbon 1 and X, this sigma bond, is displaced towards the halogen atom, which acquires a small positive charge. Then this X will acquire a small negative charge, and this results the adjacent carbon atom C1 acquiring a small positive charge. And this small positive charge carbon, this one will again pull electron towards itself from second carbon, and this one will acquire a partial positive charge, which one also pull electron from the third carbon, and this effect dies on the fourth carbon atom. Thus, this polarizing effect by the displacement of bonded electron along a saturated carbon chain due to presence of an electron withdrawing or electron pushing group at the end of chain is called inductive effect or I effect. It is a permanent effect, and this effect dies beyond the third carbon atom. Next one is the inductive effect is of two types. One is negative inductive effect, that is minus I effect. When the substituent atom or group has a tendency to withdraw electrons, it is called minus I effect. For example, this nitro group, NO2, this one is not positive, this nitro, cyano, then this carboxylic acid, fluorine, chlorine, bromine, iodine, OH, etc. These are minus I effect group. That is, this one pull electron towards itself. Next one is positive inductive effect or plus I effect. If the substituent attached to the end of carbon chain has a tendency to donate electron to this results in plus I effect. Example is methyl group, ethyl group, etc. Next, consequences of inductive effect is that number one is dipole moment. Now this carbon iodine, then it is methyl iodide, methyl bromide, methyl chloride. In this case, since electronegativity of iodine is less than that of bromine, which one is less than that of chlorine, so that the bond polarization takes place in carbon iodine, this one is less than carbon bromine, which one is less than carbon chlorine, so that this dipole moment, this methyl iodide, this one is 1.64 dBi, this methyl bromide, this one is 1.79 dBi, and methyl chloride, this one is 1.83 dBi. Now, reactivity of alkyl halides, that is since this due to presence of halogen atom, which one will pull electron from carbon towards itself, so that this carbon halogen bond, this one become polarized, and so that the reactivity of 3-degree alkyl group is greater than that of 2-degree alkyl group, which one is greater than that of primary alkyl group, which one is greater than that of methyl halide. That is, tertiary alkyl halide is more reactive than secondary alkyl halide 2 degree, which one is more reactive than primary alkyl halide, that is 1 degree, and which one is more reactive than methyl halide. Next one is the acidity of monocarboxylic acid. Now, this one is acetic acid and this one is chloroacetic acid. Now, since methyl group, this one push electron towards this carboxylic carbon atom, so that thus this proton release will become difficult. But in this case, chloroacetic acid, in this case, this chlorine will have, this one will push electron towards itself. That is, this chlorine has minus I effect, and while this methyl group has plus I effect, so that this chlorine will withdraw electron from this carbon, so that this carboxylic group, this one will donate proton easily. So that this acidity of monocarboxylic acid is this, its acetic acid CH3COH, this one is less than chloroacetic acid. Now, basicity of amines. Now, in amines also, the inductive effect of methyl group or alkyl group, this one will increase the basicity, so that this primary amine will be less reactive than secondary amine. Now, next one is electromeric effect. The temporary but complete displacement of an electron pair towards one of the two atoms joined by a multiple bond occurring in the presence of an attacking reagent is called electromeric effect. Now, this electromeric effect is also of two types. One is plus E effect and another is minus E effect. In this case, this alkene, this carbon-carbon double bond, this alkene added a proton. In this case, this is positive attached to this carbon, and this electron also comes towards this carbon atom, to which this positive charge is attacking reagent is attached. So that this effect is called plus E effect. While in minus E effect, this one is in case of carbonyl group, this attacking reagent goes to this carbon atom, while the electron pair will shift it towards this oxygen atom. So, this one is the minus E effect. Now, difference between inductive effect and electromeric effect, that is, inductive effect is a permanent effect, while electromeric effect is a temporary effect. In inductive effect, no attacking reagent is required, but in electromeric effect, attacking reagent is required. Again, in inductive effect, the electron is partially shifted, while in electromeric effect, electrons are completely shifted. So, these are some differences between inductive effect and electromeric effect. Next one is hyperconjugation or Baker-Nathan effect. Now, when a carbon-hydrogen bond is attached to an unsaturated system, the sigma electrons of the carbon-hydrogen bond enter into conjugation with the unsaturated system, and this is known as hyperconjugation. Now, in this case, this carbon hydrogen bond is attached to the carbon carbon double bond, so that this carbon hydrogen bond, this one will have no bond, and so this one is also called no bond resonance. And this effect was first observed by Becker and Nathan, and so that this effect is also called Becker-Nathan effect. Now, reaction intermediates. Now, the reaction intermediates are generated by breaking of bonds in the intervening steps between the reactants and product. That is, in between reactant and product, some short-lived species are formed, which are called reaction intermediates. And these are very short-lived species and cannot be isolated, but their existence is proved by spectroscopic studies. A brief description of some common kinds are given as follows. Now, one is free radicals. Any species which contains an unpaired electron in its valence shell is called a free radical. Now, in addition to heterotic fission of a covalent bond which produces carbocation or carbanion, some reactions are known which involve the formation of intermediates by homolytic fission of covalent bonds, which both the atoms possess unpaired electrons. These fragments are neutral species and known as free radicals. Heterotic homolytic fission, this 2 electron carries by each atom, so that this one A dot, this one is A free radical and B free radical, etc. For example, this chlorine in presence of UV light or heated, this one will break homolytically, so that 2 free radicals are generated. Now, chemical method of preparation of short-lived free radicals, that is tetramethyl lead decomposes to form lead and methyl radical. When tetramethyl lead is heated, this one forms lead and methyl radical. Next one is carbocations. An organic species which has a positively charged carbon atom bearing 6 electrons in its valence shell is called a carbocation. That is, a carbocation contains 3 bonds and 1 positively charged. Next, formation of carbocation by number 1 by direct ionization of alkyl halides. Since halogen atom is more electronegative than carbon, so that this carbon halogen bond, this one breaks in such a way that the shared electron pair will be shifted towards the halogen atom, creating this positively charged carbon center, that is carbocations. Next one is by deamination of amines by nitrous acid, also produces carbocations. Next one is by protonation of alkenes and alcohols followed by dehydration. This one also produces carbocations. Next one is structure. The structure of carbocation is a planar one, because this carbon atom is sp2 hybridized. So next, stability. Among the alkyl carbocations, tertiary carbocation, that is 3-degree carbocation, is more stable than secondary carbocation, that is 2-degree carbocation. Which one is more stable than primary carbocation, that is 1-degree carbocation? Which one is more stable than a methyl carbocation? Next one is reactions. This carbocation, this one undergoes combination with a nucleophile. And also this carbocations, this one release a alpha hydrogen, creating a alkene molecules. Next, detection. This carbocations can be detected by by NMR spectroscopy. Next is carbanions. Now, carbanions may be defined as an anion in which negative charge is carried by a carbon atom. Now, formation. This carbanion may be formed by heterotic fission of a organometallic compound such as alkyl lithium or Grignard reagent, or from carbonyl compounds having alpha hydrogen atom also produces carbanion. Now, this structure of carbocation is that this carbon atom having carbon ion is sp3 hybridized, so that this carbon ion is sp3 hybridized, that is this one is pyramidal in structure. Next one is stability. The stability of alkyl carbon ion is that the methyl carbon ion is more stable than primary carbon ion, which one is more stable than secondary carbon ion, which one is more stable than tertiary carbon ion. Next one is reactions. These carbon ions, now these carbon ions add to another other carbonyl compound to give a bond. Now this one is student is, thank you.